Hello, this is Mr. Henry, and welcome to lesson 1.6, representing functions as rules and tables. So the essential question says, how do I represent functions as rules and tables? We have two get the goofs down below here. They both want us to evaluate an expression, and they're giving us what the variable equals. So let's see. Here it says x equals 6, so you'd plug your 6 in for the variable, and they got 46. No. If you remember that when you have a letter and a number right next to each other, that is a multiplication. 4 times 6 would be 24. And then you take the 24 plus 7, and you'd get 31. Number 2, if you plug 2 in for the g, so that looks correct so far, then you just got to make sure you're doing the order of operations correct. Here, they subtracted first, which is wrong. You multiply and divide before adds and subtracts. So you'd get y minus y equals a 2 minus 10 plus 6. And then you do this little bit of math here. 2 minus 10, it would be less than 0, so it's a negative 8. And then negative 8 plus 6 would give you a negative 2. Again, I know we haven't talked about negatives yet so far this year. It comes up in Chapter 2, but you've talked about them in Course 2. You talked about them in pre-algebra. So the past couple of years, you've seen integers. This should not be completely strange to you. If you forgot about it for this problem, that's okay. You'll get to it soon enough. We do have a bunch of vocab words here: function, domain, range, independent variable, dependent variable, and unfortunately we do need to go through them all. So, a function. A function is the relationship between the input and the output. That probably means nothing to you right now, makes no sense at all. It'll make more sense here in just a second. So for now, copy it down. When you understand these things, we're going to go through them in more detail right after we go through the vocab. The domain. The domain is the input of a function. The range is the output of a function. Independent and dependent variables. An independent variable is a variable that is not affected by another variable. A dependent variable is affected on another variable. It depends on the value of the input. So get these copied down, and then we're going to see what this actually means. You might want to pause the video if you're still copying. I'm moving on to the next slide. So here we have this pretty picture, and you have it on your note sheet as well, except yours is not in color. Mine is. And this picture is actually from a Dr. Seuss book, but I like this because it kind of describes, it's a way to think of a function. So a function, it has its input, which we call the domain. Okay? So you plug in something into the function. This machine would be an example of your function. It's some magic machine that does something. You don't quite understand what it's doing, but you plug something in, the machine does something with it, and then it spits out the output. I spelled out wrong. And the output is known as the range. Okay, so you've got input, which is your domain. The function is the machine. It kind of does something. It's the relationship between what's happening from here to there. And then you have your output, which is what comes out of the machine when you're done. Okay? And for this to be a function, every one of these, every input, makes one output. So each in makes only one out. So each input makes only one output. That's important for something to be a function. We're going to talk about that later on throughout the lesson as well. So, now that we have maybe a slightly better understanding of what a function is, let's see how they actually look in math. Here we have ourselves a little table. And it says identify the domain and range of the function. Now, I'm telling you that these are functions. There's something happening between this input and this output. We maybe don't know what it is. It might be something strange, but I'm telling you it's a function. So all we have to do now is identify the domain and range. The domain is the in. You can remember because it has the word in it. So domain is the input. So 10, 12, 15, and 14. Those are the inputs. That's what you're plugging into your machine. The range is the output. So that would be the 3, 8, 16, and 12. We don't know how it's getting that. It's just some magic machine. It spits out answers, but that's what it got for the output. So domain is the input. Range is the output. Letter B, same deal. Domain, it's the ins. So you just copy down your inputs. That is your domain. The range is the outputs, so 2, 1, 0, negative 2. And that's the output. Pretty easy so far. Hopefully you're understanding that at least domain and range are the inputs and outputs. That's all we're getting to right now. Here are two problems for you to try, letters C and D. Same deal, just list the domain and range for each problem. Go ahead, pause the video, do it right now, and we'll get back together in just a second. Okay, you should be done, so let's see. Domain here is 6 and 6 and 9 and 15. Outputs would be 4 and 8 and 7 and 1. And technically, you don't need to write 6 twice. And actually, to be perfectly honest, this guy, not a function. It's in a table, but it's actually not a function. And when we're talking about what makes something a function and not a function, in the next example, we'll see why that last problem is not a function. Okay? So just label it not a function, and we'll come back to it in just a minute. But letter D is a function. Domain is negative 3, negative 8, 7, and 6. Those are the inputs. The outputs would be the 3, 8, negative 7, negative 6. The outputs range. So you plug in the domain, you get back out the range. Now, what makes something a function and not a function? Why is this not a function, but everything else was? Now, I guess we also have some different notation here. Here you see the input and output. Instead of being a table like the last one, it's kind of more of like bubbles. You'll see this too. If you wanted to write this out as a table, you could. You'd say 4 is going to 0, 4 is going to 1, 6 is going to 4, 7 is going to 4. So each arrow is one of your inputs and output lines. Now, this is not a function. Not a function. Because if we go back up to our picture, I listed here that each input makes only one output. Think of this as maybe like a soda machine or something. If you hit the Coke button on the soda machine, for that machine to be working properly, Coke better come out. For every time you hit Coke, you better get Coke. If you hit Coke one time and you get Coke, and you hit the Coke button again, and the next time you get a Sprite, that machine's busted. That is not a function, because every time you're hitting the same input, you should get the same output. Here, we plugged in a 4 and got a 0. We plugged in a 4 and got a 1. So even though we hit the same button, we got two different answers. That is not a function. That machine is broken. If we go back to that other example we said was not a function, looky. We plugged in a 6, got a 4. Plugged in a 6, got an 8. That is not a function, because if you're plugging in the same thing and getting different answers, something's not right. You should always get the same answer every time you plug in the same number. Okay? So that's why this is not a function. Every input has only exactly one output. If you have two outputs for the same input, it is not a function. That's why this is not a function. This 4 cannot be going to 0 and 1. All right, let's check out letter B. 0 is going to 0, 1 to 2, 4 to 8, 6 to 12. I don't see anything wrong there. Each input has one output. So this is a function. Is a function. And don't forget, this is also domain and range. Okay, I would like you to try letters C and D. See if you can identify if these are functions. Pause the video, do it on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so let's see. Letter C here. This arrow is going to 8, so 6 has one output. 4 has one output. 9 has one output. 0 has one output. So everything on the input, if I hit 6, I get 8 every time. If I hit 4, I get 3. If I hit 9, I get 5. 0, I get 9. It does not matter that this one's not used. It only matters that every time you have an input, it only goes to one output. So this is a function. Letter D. 8 goes to 5, 3 goes to 0, 7 goes to 6, 8 goes to 4. That is a conflict. This input, if you hit 8 here, you get a 5, you hit 8 there, you get a 4, that machine's busted. You should not get a different answer for hitting the same button on the machine. So this is not a function. Okay? So functions, every time you hit the same button, you get the same answer. If it's busted, if you hit the same button, you get two different answers, it's not a function. The machine's busted. I would like you right now to do these 3 problems from the textbook. The first one here asks you to just identify the domain and range. That's all you're doing. List the domain, list the range. The second problem asks you, is that thing a function? Yes or no. So go ahead, pause the video, do these 3 problems right now, and we'll get back together in just a second. Okay, number 1, domain. Domain is 0, 1, 2, and 4. Range is 5, 2, 2, and 1. By the way, this is a function. It's okay that 1 goes to 2 and 2 goes to 2. It's okay if different inputs have the same output. I mean, if you have a machine and you have 2 different buttons that say Coke on it, you expect to get Coke out of both of them. But you would not expect one Coke button to give you 2 different types of sodas. Okay, number 2. It says tell whether the pairing is a function. So is this a function? So 3 goes to 1, 6 to 2, 9 to 2, 12 to 1. That is a function because every input goes to one output. I don't have a 6 going to 2 different things. So this is a function. Number 3. 2 goes to 0 and 2 goes to 1. That is a problem. Right there I can automatically say this is not a function because you cannot have the same button giving you 2 different answers. You don't hit the Coke button and get a Coke and then get a Sprite. That doesn't work. That machine's busted. Not a function. Now, example 3. We want to make a table for a function. So here it says the domain for a function y equals 3x is 4, 5, 8, and 12. Make a table for the function, then identify the range. So it gives us the domain. It's giving us the input, which, by the way, the inputs of a function are the x values. So it's telling us to use these numbers, 4, 5, 8, and 12, as your inputs, the domain, the x values. It then wants us to find what are the outputs, the y values. Y values are the outputs, the range, whatever you want to call them. So to find the answer, we now know what this machine is doing. It's saying you take the input, you times it by 3, and that gives you the output. So let's do that. So you hit the 4 button. Boom. 4 times 3. The computer does that and spits out, oh, you get 12. Then you hit the 5 button on the machine. And it goes, machine says, oh, you take 5 times 3, and it spits out the answer 15. And that's your output for that button. And you plug in an 8, it spits out 24. You plug in a 12, hopefully you got the idea here, it's going to spit out 36. Because it takes the input, times it by 3, and that's the output. That's what this function here told us to do. X value times by 3 equals the y value. So now that we've plugged our things in, we have our range. We have our outputs. Our outputs of this function were 12, 15, 24, and 36. Those were the outputs. Let's look at letter B. Same deal. Now here we have make a table of the function 2x plus 3 equals y. So there's the function. If the domain is that. So our x values, which are the inputs, which is the domain, I mean, those all are, they have the same meaning. X values, inputs, domain. So those are the 0, 3, 5, and 9. And then the outputs, which are the y values, which in this case is the 2x plus 3. That's the output, which is also the range. Again, all of them are the same, have the same meaning. So let's find that now. So we're going to take our x values, times it by 2, add it by 3, and then that's the y value. So let me write it down here. There we go. So watch this. We're going to take the x value of 0, plug it in. 2 times 0 is 0. 0 plus 3 is 3. So when you plug in 0, the y value, the output, the range, is 3. Okay? Now you plug in 3. 2 times 3 is 6. 6 plus 3 is 9. So when you plug in a 3, the function spits out a 9. You plug in a 5. 2 times 5 is 10. 10 plus 3 is 13. Now we know what this function did. It took it times by 2 and added by 3. And last one, if you plug in a 9, 2 times 9 is 18. And then 18 plus 3 is 21. So we now have all of the outputs for this function. If you plug in those 4 numbers, you get those 4 outputs. So the last thing it tells us to do is identify the range, which is 3 and 9 and 13 and 21. Again, the range are the y values. The domain is the x values. And there's one I'd like you to try. Here's letter C. It says make a table for the function where the domain is, and I gave you 4, 7, 8, 12, and 15. Then identify the range. So what I'd like you to do right now, go ahead, pause the video, do this problem on your own, and then hit play, and we'll go through it together. Okay, so the x values and the y values. The x values are the inputs, the domain, which we said is 4, 7, 8, 12, and 15. The function was y equals the x value plus 4. So let's see, if we plug these in. If we plug in a 4 for the x value, y equals 4 plus 4 is 8. I'm not going to go through all of them this slow. 7 plus 4 is 11. Now, the rest we're going to do in our heads. Let's just imagine it. 8 plus 4 is 12. 12 plus 4 is 16. 15 plus 4 is 19. So each of these x values, we plugged it in. We added it to 4 because that's what this type of the problem told us to do, the x value plus 4, and we got our y value. So the range here are the outputs, the 8 and 11 and 12, 16, and 19. That is the range. The last thing that we have to do, the last example here, is if they excuse me, what if they gave us a table and they wanted us to write the rule? Remember, the inputs are the x values, the outputs are the y values. So what are you doing to this guy to get that? What's happening from here to here, here to here, here to here? And it has to be the same for all of them. What's the pattern? So when I'm looking at this, my first guess is to get from here to here, I would add 2. Now, if it's add 2, it has to be add 2 for all of them. So let's check. 1 plus 2 is 3. Okay. Plus 2, plus 2. All right. So we know that we're going to take the x value, we're going to add 2 to it, and that gives us the y value. Took the x value, added 2, we got the y value. That is the function. We were able to write the rule. The y value equals the x value plus 2. Let's try letter B. Again, input, output. So what's happening to the x value to get to the y? In every single case, what's the pattern? And it has to be the same for all of them. So let's see. I mean, I could try. If I add 1, 1 plus 1 is 2. If I add 1 here, 2 plus 1 is 4? No. So plus 1 didn't work. What about, well, the only way to get there is times by 2. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 5 times 2 is 10. All right, so times by 2 worked. So we're going to take our x value, times it by 2, that says 2 times x, and that gives us the y value. We got it. That is our function. Each input, you're taking it times by 2 to get the output. So you take the input, the x value, times by 2, and that gives you the output. Here's letter C and D, and I'm telling you right now, letter D is a challenge. It is harder than the rest. You should be able to get letter C. You might struggle a little bit with letter D, but give it a try. Go ahead and do them both right now. Okay, if you're not done, pause the video, keep working. But letter C we have, let's see. Well, nothing changed there. Here my sign changed. It went from a positive 3 to a negative 3. Okay, so the sign is changing. So how do you change the sign of a number? I mean, how do you make it go from positive to negative or negative to positive? I guess, well, if you take the x value and you times it by negative 1, because 3 times negative 1 is negative 3, Negative 4 times negative 1 is positive 4. Yeah, so if you take the x value and times it by negative 1, it gives you the y value. For those of you who don't know, anytime you take something times by negative 1, it changes the sign of the number, and that's all it does. So it changes from negative to positive and positive to negative. Letter D. I'm going to give you the answer first, and then if you want to pause the video after I give you the answer and double check and see why it's that, you can. The answer here is y equals 3x plus 2. If you want to pause the video and check and see why it's that, go for it. If not, I can just go through and kind of explain a little bit. Now, here's about how you would get this. Now, I find it easier to look at the positives, so I'm going to stick in this area. The first one from 0 to 2, it doesn't really help us much. I mean, it's getting bigger by 2. But you look at the next one over, and it's getting bigger by like 8. So then what you do is you think, okay, well, about how much bigger is it? So 3 times what gets you around 11? Well, it's around times by 3 or times by 4. So we really didn't narrow it down yet. So you look at the next one over. 6 times what is about 20? Well, that's also about times by 3 or times by 4. Because this times by 3 is 9, times by 4 is 12. So it's actually a little bit closer here. 6 times 3 is 18. 6 times 4 is 24, so it's a little bit closer there. 12 times 3 is 36. 12 times 4 is 48. So that one's really far off of 4. So it's not 4. So it's going to be times by 3. That's the times by 3. So you say you take this number, 12 times by 3 is 36. So times the x value times by 3. And then what would you have to do to get the y value? Well, you would add 2 more to it. Here, 6 times 3 we said was 18, plus 2 more gives you 20. 3 times 3 is 9, plus 2 more gives you that. And if you check it, it works for the rest of them. 0 times 3 is 0, plus 2 is 2. Negative 2 times 3 is negative 6, plus 2 is negative 4. So the pattern works out. It's just a little bit harder to get. If you got it, hey, great job. That's a hard problem to do. Here is the last 2 problems for the day. Pages 37, numbers 4 and 5. Go ahead, pause the video, do these 2 problems on your own. When you're ready to continue, hit play, and we'll go through them together. Okay, it says here, make a table for the function y equals that with that domain, and then identify the range. Okay, so we did a bunch of these before, so we need to make an xy table. So x, y, let's see, 10, 12, 15, 18, 29. Oh, 9. Okay, so this is number 4. Now I need to figure out what the y values are. So I'm going to take the x value, which are the inputs, take the x value, subtract it by 5, and that gives me the y value. So just take each of these minus 5. So 10 minus 5 is 5. 12 minus 5, 15 minus 5, 18 minus 5, 29 minus 5. And then when we identify the range is just the outputs. So 5, 7, 10, 13, and 24. So to make the xy table, to finish the function table here, we took each input, the x values, subtracted it by 5 because that's the function they gave us, and that was the range. All right, number 5. It says, write a rule for the function, identify the domain and range. Okay. Well, domain and range is easy. I'm going to do that first. So the domain is 1, 2, 3, 4. Range is 8, 16, 24, 32. All right, now, what is the function? So what's happening from here to there? Well, it's either plus 7 or times by 8 or something really weird. But let's check these first. Well, 2 plus 7 is 9, so it's not plus 7. 2 times 8 is 16. Alright, so this one gets 2 checks. It might be right. 3 times 8, yeah, 4 times... Alright, we got it. Function equals, you take the x, y. You take the y value, the output, or the y value is the x value times by 8. So we got domain, we got range, and we've got function. Now, the one word we really didn't, or the two words we didn't use in the vocabulary much today were the independent and dependent variables, and this would be an example of where they come in handy. The independent variable, we said, is a variable that is not affected by something else. The dependent variable does depend on something else. Well, here, x is our independent variable, hours. The hours does not change. The dollars depends on the number of hours you worked. I mean, if they're talking about pay, so the amount of dollars you make depends on the hours you work. So this depending on that means this is the dependent variable, which is the y variable, and x is the independent variable. In science class, when you get to graphing, you'll talk about independent and dependent variables as well. It's the same deal here. The independent variable is the x, the dependent is the y. Last thing here, how do you represent functions as rules? See if you can write down an answer, a sentence, a two, a summary. Just kind of get your thoughts down about this entire lesson. So how do you represent functions as rules? Go ahead, pause the video, do it now. When you're ready to continue, hit play. Alright, here's what I have. I have identified the pattern between the input and the output. So you look for this pattern. Make sure the pattern works for all of the inputs. Then you write the rule as, and I put this thing, which probably looks really weird right now, but I really mean is like the output, which is the y variable, and the pattern input. So if the pattern was like plus 2, you take the input plus 2. If the pattern was like times by 5, you take the pattern, the times by 5, the input, like that. So that's kind of what I mean by that. It's kind of ugly, but I didn't know a better way to write it. Homework, page 38, numbers 3 through 15. This has been lesson 1.6. Thank you very much for watching.